Hi everyone, my name is Rosa Alonso and I'm here to present the solution to challenge 2 from the Cabi Coders. We are Rosa, Catherine, Amalia, Chilem, and Mark have worked together over 2 days to produce the following solution. A bit on the challenge, we had a big data set with a lot of risk and mitigation data for different projects, and we were asked to stay ahead of the risk. Let's try to turn all this data into action and show like a way clear picture for everyone, for our stakeholders in this project. A bit of the data. It was, as I mentioned, very big, over 30,000 rows of data. And this was quite patchy. There were incomplete records, typos, and vague risk descriptions, but that's how real data is in the real world. So that was great. But we had detailed risk probabilities that help us on forecasting how we approach this challenge. First, we did a bit of team strategy and project managing. We did a Gantt chart. We worked through agile methodologies, through a Kanban board to split the task, and then right on, we start with data cleaning and exploration to get an idea what valuable we had in that data set, and then start with the metric calculations and how it was more useful to visualize. Then we develop the dashboard, the prototype. We did some user testing with AI and real people, and finally we integrate all this feedback into the final product. We use tools such Miro, R&R Studio, ChatGPT, GitHub, and Shiny apps, which most of them are open source and free to use. And here I'll pass it now to my colleague Catherine to talk you through the solution in itself. This solution can help you tell what can go wrong and how much it's going to cost us.
Okay, so here is an overview of our dashboard. At the top of it, you can see the recommendations we have provided based on our analysis. And at the bottom, we have some key metrics we thought would be useful to show, as well as at the side, we have drop downs so you can filter the data based on any specific subset of data you'd like to see. The next tab here is risks. So part of our exploratory analysis was to look at the number of risks reported over time, but also the emergence rate of these risks when they were first raised. And here you can see there's some trends. So May and September seem to be when the highest amount of risks were raised. And at the bottom, we have also shown the number of risks and mitigations per project, which allows project managers to see that distribution and maybe focus more on the projects that have higher amount of risks or mitigations. Next, we also have a tab on mitigations. So we thought it'd be interesting to see the impact that mitigation had on risk probability and risk cost as well. So in the bottom left quadrant, you can see here that this is where the majority of the data lies. So the average cost per risk category found that both probability and cost decreased. I will now hand over to my colleague Amalia.
So, following on to risks and opportunities, because in our data set we had myriad different risks, we wanted to condense those into smaller clusters. So, this is risks that go together. And this is useful because uh, typically, if you tend to have one type of problem, you'll have the other as well in your project. So, for example, if you have business and strategy risks, you will tend to also have project management risks. Because if there's moving goalposts or poor leadership, that will affect your project management. And that's kind of what we find in the data set as well. Then we also wanted to look, okay, maybe in a project we have a lot of risks, but that might not necessarily translate into a lot of costs. So here we're looking at the top 20 projects where we can save the most by addressing the different risks we have. And here is color coded by the different 4 clusters of risks that we identified in the data set. So you can see project 605, it's the one where we can have the most savings if we address the risks.
Okay, next we looked at doing our predictive analysis, in particular looking at risk velocity. And the first variable we looked at was risk criticality, H1 being the most critical type of risk. And I plotted the rate of change compared to time difference. So we can see that within the first 300 days, this is when the highest rate of change occurs, and then it steadies off. Similarly, I did the same for looking at the pre-mitigation cost and pre-mitigation probability of risks. And within the first 300 days, this is when the highest rate of change occurs, suggesting that these risks should look at and potential mitigation solutions to be delivered.
This is an area chart that forecasts 2019 total pre and post factored cost variables. The forecast based on mean of 2016 to 2018 total pre and post factored costs. I'll now pass to my colleague.
And lastly, this plot visualizes the predicted values for pre-mitigation costs against the respective cost savings that we can get if we implement those mitigations. And this is based on our forecasting model. It serves as an example for how different risk clusters and criticality levels might influence costs and the savings that we can get. In the future, the plan would be for this to be used as a tool where the user can just input their various risks and their different parameters to get a forecast for their particular project. But in the interest of time, we have here a static plot. And the colors represent the different risk clusters, such as strategic and technical risks. Then the shapes and the size influence the criticality level, so high, medium, or low. And by looking at this, a few examples, you can tell, for example, that not all risks result in savings. So, for example, some points show negative savings, meaning that mitigation actually increased the costs on a project.